Hello, good morning, good evening. My name is Anas Aziz, and this is my MLOps assignment submission. And this is an end-to-end machine learning pipeline that predicts heart disease risk from patient health data using the UCI Heart Heart Disease dataset. So over the next few minutes, I'll walk through the full pipeline: data preparation, model training, content containerization, the live API, and the monitoring with the CVCD pipeline. So for this, as you can see, this is the folder where the entire project is developed, and you can see here the data file, the data folder, which holds data, and this is the source file. And as we can say, like the project follows a standard MLOps structure. Data acquisition and cleansing script live in these two folders, data and the SRC. So model training and the experiment tracking happen in the train PY using ML flows, and the trained model is served through the faster API, the main API. The containerized with Docker monitoring is handled with Prometheus and Grafana, which we will see later point. Deployment manifests are provided for Kubernetes, and everything is wired together with a GitHub action for the CI/CD pipeline. So let me show you this is the Docker file. As I mentioned, this is our requirement. So we can go through each of them during our demo session. So if we talk about the data set, so the data set is the UCI Cleveland Heart Disease data set, and we considered 303 patient records with 13 clinical features like age, resting blood pressure, cholesterol, ECG results, and we can check it here. This is our data set. So these all we have included in our downloaded data here, download data, and acquisitions and cleansing and everything is done in the source SRC file here. So the EDA notebook explore class balance. Let me show the EDA notebook as well here. This is so this show the explores, or I mean I can say this EDA notebook explores class balance, feature distribution, and correlations. For example, here we can see this charts. One second. Let me go to the reports. These are the different charts generated, and this is the summary. Let me open it as well. Yeah. So for 303 patients, we can see this, the standardization. Okay, moving to the next step for the model training and the experimental training. So for this, I am again moving to the SRC folder, and here we have done feature engineering uses the scikit-learn and handling numeric scaling and the categorical encoding wrapped inside a full sklearn pipeline. So processing and the model travel together as one saved artifacts. This is the train PY I'm talking about, and compares multiple model logistic regression and the ran random forest, and logs parameter matrix and artifacts using MLOps with the compatibility fallback in case MLflow tracking is offline. So let me show you the model card. Before moving to the model card, let's move to the next steps. How we have done the containerization with Docker. So this is our, I already opened the Docker app here, and this is our container, and this holds the API with this name, Heart Disease API. And we also maintain the Grafana and the Prometheus for the dashboard and the monitoring purpose. So here we can say like the train model and the fast API app are packaged into a Docker image. The doc here is like this. The Docker files uses a slim Python 3.11 base, install dependencies, copies in the app source and model files, and runs as a non-root user for security with a built-in health check. So when we execute this, so these are already live now. So if I go to, yeah, if I go to this local host, as you see, yeah. So my app is running right now, and we can check the health of the app as well. I'll put /health, and it is showing the health of the API, and this is also okay. And we can see it in the form of the JSON here. And now we can move to the we can move toward the demonstration, and for this we can open the docs. Yeah, so this API is documented. Okay, so the API is documented automatically with Swagger UI. This is a health endpoint readiness check. Okay, and how it will work, let me show you. So first place we have to go to the post method for the login, and we can click on the try it out. So we created two users for it, one for doctor and one for researcher. So let me log in with the doctor's credentials. I can execute it, and here it will generate an token number for me. Let me copy this token, and I have to authenticate it first. I have to go to authorize button. I have to paste it here. So this is authorized now. I closed it, and now I have to go towards the prediction part, and I'll start with the, so this is some existing values in the JSON format. So let me try with this value first. So yeah, this is executed, and here is the response. So with this input, we can see it is a low risk of heart attack, okay, with the confidence of 0.8. And suppose if I increase the chest pain to 4, and let me execute it again to see the difference. Okay, so now you can see the risk label is increased and the confidence is also decreased to 0.5. Okay, so that's how this model works. And coming to the next point, now we can see it in the uh, Grafana and the Prometheus as also how these are works here. So this is the Grafana. Okay, I will go to the container. Okay, I can run it in the browser. Okay, that's how my Grafana open, and here we can do the monitoring and check based on our recent flows, and everything we can check here. Same for Prometheus, which I already opened. Okay, we can write some queries, alert, and the status to check the overall status, and the we can monitor the overall heart disease. This is an overall tracker. And if I summarize all these points, so this for the observability, we can use this. Uh, we have the YML file generate for this, and these this what these will do, this will bring up the API alongside Prometheus and the Grafana. Okay, and the Prometheus scraps the matrix endpoint tracking request counts, and latency Grafana visualize that data on a pre-provisioned dashboard, so I can watch request volume and the response time update live as a send predictions. So let's talk about the next points, Kubernetes and the CI/CD. So if I go back to my folder, so here the folder K8s holds the information of the Kubernetes. So for the production style development, the K8s folder includes a deployment and service manifest. So this same container image can be deployed to any Kubernetes cluster, and for continuous integration, a GitHub action workflow automatically runs the test suite and builds the Docker image on every push. And we also I also moved this program to GitHub repository. Let me move to that part. Second, here. So here you can see I moved all the code to this repository named Heart Disease MLOps project, and all the files are visible here. It includes the requirement, txt Docker file, the code, screenshots, everything. And if I open particularly screenshots, so all the architecture, confusion matrix, correlation, histogram, and the heat map, everything, all the informations are available here. So for the production style development, this folder includes a deployment and service manifest, as I mentioned. And next we move towards the testing and the wrap-ups. So if I go back, so this is my testing folders. Okay, you can see some test files are generated here. So this folder covers data preparation, data feature engineering, the model, and the API itself. Okay, as you can see, 4 files are here, and all run automatically in the continuous integration that covers the full pipeline from raw data to a monitor, tested, containerized, and deployed prediction service. So that's the whole project I have developed here. And if I show the final report as well, where I placed all the details and the screenshots. So this is the complete setup and installation. The different files are generated. This is the data analysis, and this is showing the balancing of the data. So 164 plus 139 for the 303 patients. So where 164 comes with no disease and 139 with the disease. And this is the heat map. And here we have a confusion matrix, the ROC curve. And yeah, this is the detail of CI/CD pipeline. And yeah, this is the monitoring log we have covered in the Grafana. Okay, so this is the behavior, how it works. And this is the overall architecture. And if I show the if I show the final report, so yeah, this is my training result for both the models. For the logistic regression, um, the AUC is reached to 96%, and for the random forest, it is 94%. So overall, like we can say, the logistic regression is the most much better here to address this heart disease problem. And the F1 and the F1 and the accuracy also looks in the good format, near to 1.88. So that's all. And thanks for watching. And um, uh, thank you.